Welcome to InsideAM, a brand new podcast series brought to you by NDT specialist Theta Technologies. Here's what to expect from this episode.
If you want to use additive manufacturing, let's say for serial production, is really thinking AM from the start.
Is this a material that people need to start taking seriously when it comes to 3D printing?
I think yes, speed is really something that is quite exceptional with this. And now you can guarantee that to the end user that the part doesn't have any defects inside. Being able to very quickly identify if a component is good or not good, that's definitely an added value in the process.
When all those kind of complex shapes are put together, do you think Tensile is able to cope now with AM? We're back with another episode of InsideAM, a podcast series brought to you by NDT specialist Theta Technologies. I'm here in Telford at the site of Ricoh 3D, and I am thrilled to have Enrico Gallino here with me for this podcast episode. Enrico, thanks for joining me.
Yeah, thanks for the opportunity, Chris. Really nice to have some time together, have a chat about additive manufacturing, a subject that I love, I'm passionate about.
Well, hence why we've got you on the podcast, because we couldn't have a podcast about AM without you there. So we're going to talk a bit about composites as a material, as opposed to AM. We're also going to talk a little bit about a case study, a project that you did with Theta Technologies when it came to inspection. But before we get to that, can you just explain a little bit about kind of what it is you do here and what Ricoh does?
Yeah, so I'm Enrico. I'm one of the senior engineers in the Ricoh 3D team. I've been with Ricoh for roughly 7 years now. I joined the company in 2017 as a material engineer. That's my background. I'm a background in material science. And since 2019, then my focus in terms of day-to-day activities has been to support the customer of our print service, developing application, and really supporting them with the adoption of additive manufacturing technology as a manufacturing tool for producing their components.
Just following on from that, we recently did a podcast with AM UK, who held their latest members forum recently down in Luton. You held a similar event the week before. Just talk to us about what that event was about and what you were trying to achieve from hosting those kind of events here at the site in Telford.
Yeah, so we hosted our Beyond Print event at the end of February, and it was a day really around our partners. We work with a lot of different companies in the whole additive manufacturing ecosystem, from software company helping on the design side, on the management of the production workflow. We had company involved with the post-processing, with 3D scanning, for example. And the idea was to bring all these company together and give them the opportunity to showcase to some of our customers what are the service and solution they can offer, because as a company, we really believe that it's not just down to Ricoh driving adoption of the technology, but it's really by working and collaborate with other companies in the industry that we can foster adoption of the technology. So the purpose of the days was really to showcase the latest technologies available in the AM industry, and now this service and technologies joined together can really help drive adoption of the technology, of the additive manufacturing technology.
And when it comes to that adoption, where do you see that really taking off, and what are you seeing as a company where this is really starting to take off now?
I think what we really see, although in our case we still see additive manufacturing used as a prototyping technology, we see more and more companies start using it for serial production, also end-use application. And that's, since we started our 3D printing service business in 2019, we really see a growth of the use of additive manufacturing for serial production across many different sectors. So we are sort of sector agnostic in terms of application. We have we support customer in different verticals, and we see in all these different verticals company using more and more the technology for serial production.
And we've talked about on this podcast before, and we've had conversations about this in terms of this knowledge share, the reason why you're putting on events like you have done recently, and the fact that AM UK have done the same. In terms of that knowledge sharing around AM, do you think it's lacking?
I think it's, a lot of the work we do is most of the time is confidential. So sharing all the application we are working on, it's always a bit of a challenge in our case. But I think having those type of events where we bring people from the whole IAM ecosystem together, so from end user, a software companies developing different type of technologies. It's and having those opportunity for these people to come together, talk to each other. I think that's a great way to make people aware of what's available out there, and might spark some idea and generate some food for thought for them. They can get away with all those information and potentially use them later on in their product development process.
And in terms of that process, so there's a lot of processes involved with AM that perhaps companies that have used more traditional manufacturing methods won't have experienced before. As that end-to-end kind of solution, what is involved, just so that if somebody's watching this and thinking about that actually AM is the way forward for us, what do they need to start to think about before they adopt this?
I think one key thing is, if you want to use additive manufacturing, let's say for serial production, is really thinking AM from the start. So from the idea, and when you start designing your component for production, and really considering all the benefit, but also the limitation in terms of design of each technology. Also think about the material you want to use. What are the requirements for your component? That's really critical. So really assess why you want to use additive manufacturing. What are the benefits that additive manufacturing can give you compared to traditional manufacturing technology? And then when you look at the design of the component, again, there are some design software out there that are really tailored for specific application, and that can help you optimize the design of your component, and that could be topology optimization or generative design as well. We had a couple of companies, again, attending our Beyond Print event that offer this type of solution. So really thinking of what is your application, what you need, and how best design your component for the process.
And on that, thinking about the why choose AM, have you had experience of dealing with people where they've kind of implemented AM because they think it's the right thing to do, but the parts don't necessarily lend themselves to the versatility that AM has to offer? You find that people are using AM and they don't need to?
Yeah, we print parts that might not be designed specifically for additive manufacturing, and that be the case. For example, if you're just doing your prototype work and you know already that you're gonna scale up with a different technology, but if talking with the customer, we realize that they want to use additive manufacturing for production, then it's a dialogue we need to have with the customer, and really share with them the best practice and the advice on how those parts can be really optimized for the process. So we are really here to support the customer, not just from a printing perspective, but also provide that advice and consultancy to to really help the customer make the most out of the technology we can offer.
Let's talk about materials. You obviously deal with a range of materials here in terms of 3D printing. We know polymers are kind of leading the way in terms of materials that are being used with 3D printing. How is that kind of segmented at the moment in terms of how many materials, what materials you're using and the popularity of each of those?
Yeah, so at the moment, we would say we are quite on different fronts. So from a 3D printing service, additive manufacturing service, the main focus has been since 2019 on polymers, with polypropylene being one of the unique material that Ricoh is able to offer. Then a couple of years ago, we started a strategic partnership with Impossible Object on some composite material. Again, that's quite a new technology. And again, composite is another area that we see growing from a number of different reasons, lightweighting parts, and so replacing metal in some application where reducing weight is one of the main drivers, thinking about aerospace or with the electrification in automotive. With this technology, we are also able to print material like PEEK, that is a material with excellent chemical and thermal resistance. Again, getting in application where high-performance material are really key. And then on the side of it, we are also developing our own technologies. So we are developing a metal binder jetting technology for printing aluminum. Again, one of the main drivers there is lightweighting and being able to create a more efficient component, especially for heat exchanger, heat sink. So again, looking at electrification, aerospace application. And we also got a project with our R&D team in Japan looking at ceramic printing. So again, the palette of material we are exploring is really broad.
So again, we mentioned there that the polymers have really kind of taken off with 3D printing, but why do you think metals are slower to being adopted compared to polymers? I know polymers have been around a bit longer.
Yeah, I think metal, there are some challenges with the printing, and also you are looking at high value application in some cases where really the qualification process for producing those components could take longer. But we also see metal now emerging in aerospace, medical application. More recently, I think defense is another sector where we see a lot of metal application and a lot of investment put into additive manufacturing. So yeah, I think it's really down to the challenge of printing the material, also the speed of the technology, cost, as well as being always seeing a bit of a barrier in some applications. So with cost coming down, machine becoming faster, more reliable, I think that's all contributing to a wider adoption of additive manufacturing in general.
Let's go back to composites. So we've got some beautiful composite components on the desk in front of us. You said it's kind of not really well known at this stage. Is this a material that people need to start taking seriously when it comes to 3D printing?
I think yes. I think it's I would say, again, composite, there are other technologies available on the market that are, again, being around for a few years now. This technology that we are focusing on, called CBAM, Composite-Based Additive Manufacturing Technology, is a relatively new technology, which has got quite a few benefits in terms of strength of the component you can produce, speed, cost of the parts, very, very competitive cost, and speed is really something that is quite exceptional with this technology. We are looking at something that is probably 10, 15 times faster than other composite technology available on the market. So yeah, really excited about this, being able to offer this technology to our customers.
Do you think this would be the material to go for? Is it very application dependent? Where do you see this being utilized or really excelling?
Again, this is a technology where, again, the focus is really on productivity. So a technology no longer only for prototyping, but really geared up for serial production. In terms of application, you can see some of the components here, aerospace or even drone manufacturing, like this drone that has been fully 3D printed, including the propeller. Industrial application, like this component, connectors for industrial application. In electronics manufacturing with some tooling and jigs for electronic manufacturing. So we also see an application in consumer application. Jewelry. We did some work for some sporting goods applications. So in terms of sectors, it's really diverse, the sector where this technology can be applied.
You mentioned a moment ago about that kind of the main difference in driving the technologies, so the materials, so polymers, less reliant on the kind of the inspection side of things and the validation. I know there is an element to it, obviously. Let's get on to talking about your previous work, your collaboration with Theta Technologies. Just talk to us about kind of what it is you did with Theta. Was it a couple of years ago?
Yeah, it was last year when we published the white paper. And the idea really at Ricoh, one of our key focuses is really on the quality of the component we supply to our customer. And as I said, this technology for composites is really geared up towards serial production. And some of the application we probably end up covering in the future, and even right now we are exploring are really high value application where guarantee the quality of the part is really key, and how you can guarantee that to the end user that the part doesn't have any defects inside. And especially with additive manufacturing, one of the benefits is to be able to create a very complex shape that might be very difficult to analyze, inspect, and validate from a quality perspective with conventional method, or might be also a lengthy process to get to that validation of the part. So really the main driver for us was, is there anything out there we can leverage to speed up that quality control process? And this is how we started the discussion and the collaboration with Theta a couple of years ago.
And what were you using in terms of that validation process that led you to kind of look for other methods?
Yeah, so at the moment, how you validate a component, you can include tensile rods into a build and validate that, which is an indirect way to validate your component because you're not testing the actual component, you're testing a standard sample. And from the data you get, you basically say the part is in that build are good or no good. You can include some inspection system in your printer. Again, that's a way where you can potentially validate your component whilst you're producing.
Image processing.
Yeah, image processing, this kind of technology. But we wanted to evaluate if there was something we can use, once the component has been printed, because in the current technology there is no an inspection system in the printer to do that. And again, a double check is always,
And with Tensile, obviously it's been used for many years on various different materials just to test those properties to see whether they're good or not. Do you think there's a real issue now that AM unlocks this more complex geometry? Do you think there's now an issue with that as an inspection method in terms of how that material works as a whole body part? When all those kind of complex shapes are put together, do you think Tensile is able to cope now with AM?
I think Tensile has still got its place as a testing method, but having something complementary that can complement, at least at this stage, what the tensile test can give you in terms of information, for me, it adds value to the process. And also having a method that is, in this case, is a non-destructive method. So you can test your component without destroying it. So, and again, you can test it at different stage of the process. Looking, for example, not at composite but metal, you can actually test your component where they are still on the building plate and not have to do all the post-processing step. For example, if you know that a component has a defect, a flaw, or a quality issue in it. And again, in this case, if I know very quickly that my component has got an issue, I can save time, and rather than complete all the stage in the post-production, I can actually start and reprint that component or that build because I know already that there are some issue.
Is that where you see it being the most valuable, to know instantly whether those parts that you...
Yeah, being able to very quickly identify if a component is good or not good. That's definitely an added value in the process, because it avoids us and even the customer to waste time on something that we know that is no good. And again, doing that on the actual component we produce and not on a different test sample, it's also an added value in the process.
No substitute for testing the part you actually intend to use.
Exactly.
In terms of the results of that case study, was there anything? So it was dog bone samples that were subject to the test, so the tensile and the nonlinear resonance test. Was there anything? Did you have any preconceptions going into that test as to what might be found?
No, not really. Actually, it was more of a learning exercise for both Theta and Enrico. We know that Theta had tested composite parts made with conventional composite manufacturing process. We didn't know if parts made with this specific process will work with the nonlinear resonance technology. So the first sort of goal was to demonstrate we can actually test part made with this technology using the nonlinear resonance technology from Theta. And then the second step was really to try to see if we can establish some correlation between the data we can get from a conventional tensile test and some measurement done with the nonlinear resonance technology. So, and we actually, what we did in this specific case study, we tested some test tension rods, see what the strength of those tension rods was, and if it was aligned with the specification, material specification. And we noticed that although all the samples were within the specified value, some of them had a lower tensile strength. And so it was interesting to see that we were able to find more flows or a higher damage index in those samples with a lower tensile strength than in samples with higher tensile strength. And then what we did was to create some artificial defects in the sample by pre-stretching some of these tension rods. And again, we were able to see a correlation between samples that have been damaged artificially and an increase in the damage index measured by the nonlinear resonance technology.
In terms of those results and that data that you were able to achieve with that combination of tensile and nonlinear resonance, how would you intend to use that data then moving forward?
Yeah, at the moment it was more of a learning exercise, as I said, but it's definitely something we now know that the technology works on this type of components. So in future, if we have a customer, a requirement for testing some complex components, some geometries where it's really key to be sure that there are no defects inside of these parts, we can still sort of rely on this technology to have quick measurement and define if the samples are good or not for the intended application.
Do you ever, when you're dealing with customers and you've supplied them with metal parts, composite parts, whatever, do they ask the question of how has this been validated? Does that ever come up in conversation?
At the moment, what we do if we have a customer that really needs a validation on the component, and for the type of application we are serving at the moment, we're generally fine with some tension rods in the build. But again, we are not working on application where components are, say, safety critical. It's definitely something, again, the more end-use application we serve, and the higher is the chance to sort of having those question asked. So, yeah, at the moment, the tension, we really validate the performance of the component we print using tension rods. As actually we tried the Theta Technologies on polymer component, and those components are too flexible for the way the signal is generated from the non-resonance technology. So they cannot really be analyzed with the Theta Technologies solution.
Not at this stage.
Yeah, not at this stage.
No. Just finally, just to finish off, in terms of AM, what do you think the industry still needs to just kind of to aid that adoption and that kind of confidence in the technology?
Yeah, I think we're seeing new software capability, new software coming to the market, and the machine becoming faster, bigger, or more productive. The cost is going down, but for me, really, it's collaboration is key. We said at the beginning of our conversation, it's really having all the different players, actors of the ecosystem coming together, working together, working with customer, and being able to unlock more application, educate end user on what additive manufacturing can do, what are the capability and the limitation of the technology, and really by working all together, it's just by joining forces we can enable wider adoption of the technology, in my opinion.
This podcast has been developed as an educational and informative resource that delves deep into the world of additive manufacturing with experiences from those individuals making it happen. If you've got a story you think those working in AM should know, feel free to reach out to our team. To stay up to date with our latest episodes, Make sure you subscribe to our YouTube channel and connect with us on LinkedIn at Theta Technologies Limited. See you next time.